AI is pretty much everywhere. It's woven into the fabric of our lives, making things easier in ways we don't even think about. But what if that same amazing tech that unlocks your phone with a glance is also quietly picking up our worst habits? That's exactly what we're getting into today, the incredibly complex and important problem of bias in AI. Right, because at the end of the day, this isn't really a story about machines or code. It's a story about us. It's about our society, our history, our blind spots. It's like we're building this giant, powerful mirror, and when we look into it, it reflects everything, including the parts of ourselves we might not want to see. So let's just start with how common this mirror has become. It's easy to think of AI as this futuristic, sci-fi thing, right? But the reality is, it's already here. It's running in the background of your life right now. I mean, seriously, think about your day. You unlock your phone with your face. Yep, that's AI. A streaming service recommends a movie that you actually genuinely love. That's AI too. It tags your friends in photos. It helps with airport security. It's designed to be this seamless, invisible assistant. But here is the massive question, the one that keeps a lot of very smart people up at night. What happens when these incredibly powerful tools start learning from us a little too well? What happens when they don't just learn our helpful habits, but absorb our worst ones? To really wrap our heads around that, we've got to pop the hood and look at how these things actually learn. It turns out there's this fundamental tension, this constant balancing act that every single AI developer has to deal with. It's called the bias-variance trade-off, and it is right at the heart of this entire conversation. Okay, so what in the world is that? Well, imagine you're teaching an AI to spot pictures of cats. You don't want it to just memorize the exact cats you showed it, right? That's useless. You want it to learn the general idea of catness so it can identify a cat it's never seen before. This trade-off is the struggle to get the model to learn the real important patterns without getting obsessed with all the random, meaningless details, the noise. And this really breaks it down nicely. On the left, you've got high bias, or what's called underfitting. The model is way too simple. It's like it's trying to capture a really complex shape but only has a straight ruler. It just misses the whole point. Then on the right, you have high variance, or overfitting. This model is the opposite. It's too sensitive. It's so focused on every tiny little bump and wiggle in the training data that it completely fails to see the big picture, the actual signal. The target practice analogy is absolutely perfect here. High bias? That's when your shots are all clustered together but in the wrong spot. You're precise, but you're not accurate. High variance? Your shots are just everywhere. There's no consistency at all. The goal, the sweet spot you're always aiming for, is low bias and low variance, hitting the bullseye consistently. Okay, so this is the moment where this abstract, technical concept of bias slams right into the real world. This is where a statistical problem becomes a human problem. This is when the code starts to have real, serious consequences. Just look at this. It's from a pretty famous study. Researchers gave an AI a simple analogy to complete. Man is to computer programmer as woman is to, and it spit back homemaker. Wow. Now, the most important thing to get here is that the AI didn't just make this up. It learned this. It learned it by reading billions of words written by humans, reflecting a stereotype that exists in our world. And it gets a lot more dangerous than just word games. Take facial recognition. A really important study called Gender Shades tested several major AI systems and found this huge gap. For lighter-skinned men, the accuracy was almost perfect. But as you move to darker skin tones, especially for women, the error rates just shot through the roof. I mean, look at that number. An audit of Amazon's system found that it misidentified the gender of darker-skinned women nearly 1/3 of the time. 31%. For lighter-skinned men, the error rate was 0. The difference is just, it's massive. And please, let's be clear, this isn't about your phone messing up a photo tag. The stakes can be life and death. The ACLU put this to the test. They ran photos of all the U.S. members of Congress against a database of mugshots. The system came back with 28 false matches, and those wrongly identified were disproportionately people of color. This kind of flawed data can create an incredibly dangerous cycle, what researchers call a runaway feedback loop, especially in policing. Think about it. An algorithm is trained on old arrest data, so it predicts more crime will happen in neighborhood A. So police send more officers to neighborhood A. Well, with more cops around, they're naturally going to make more arrests, which generates more data showing crime in neighborhood A. That new data then gets fed back into the algorithm, which says, see, I was right, and the loop just gets stronger. And this is not a hypothetical. In Detroit, a citywide surveillance network placed most of its cameras in majority black neighborhoods. In New York, the NYPD's gang database has been found to be 99% black and Latinx. It's the classic problem. If the data you put in is already shaped by historical biases, the AI will learn those biases, automate them, and then amplify them at a scale we've never seen before.
Okay, so that all sounds pretty bleak. It's a huge, messy problem. But the good news is, a lot of people are actively trying to fix it. Researchers are working hard to figure out how to break these loops and build AI that's genuinely fair.
And a lot of that work looks something like this. You start with your data, you train your algorithm, but then, and this is the key part, you test the heck out of its output, specifically looking for bias. When you find it, and let's be honest, usually do, you apply what are called debiasing techniques. Then you test it all over again. It's a cycle of train, test, fix, repeat. One of the coolest methods is something called data augmentation. It's actually pretty simple in concept. You take your original training data and you create a second gender-swapped version. So he is a doctor becomes she is a doctor. You can also strip out names and make things anonymous. Then you mix it all together and train the AI on this new, more balanced data set, so it's less likely to learn those old, tired stereotypes. And you can literally see the results of another technique right here. This chart shows how an AI maps words. Before debiasing, a word like programmer is way over on the male side of the map. After debiasing, you can see how they've pushed truly gender-neutral words like instructor right onto that center line, making the whole system more balanced. So when you look at all these fixes, they tend to fall into two main camps. First, there's retraining. This is like rebuilding a house from the foundation up using better materials. It's the most thorough fix, but man, is it expensive and slow. The other approach is inference. This is more like finding a leak in your roof and just putting a patch on it. It's way faster and cheaper, but you haven't really fixed the underlying problem with the foundation. Which brings us to the big picture. Because fixing the code, as important as it is only one piece of a much larger puzzle. The real question we have to ask is not just how we build fair AI, but if we truly can. And the road ahead is going to require a lot more than just clever engineering. There just isn't a single silver bullet for this. We have to attack it from every angle. We need the technical solutions, of course, but we also need procedural changes, like forcing companies to get regular independent audits of their AI. We need new laws that demand transparency, and we need corporations to take responsibility. We actually saw a glimmer of that in 2020 when big players like IBM, Amazon, and Microsoft all hit the brakes on selling facial recognition tech to police, specifically because of these bias concerns. And that really leaves us with the ultimate question, doesn't it? As we get better and better at cleaning up our algorithms, are we just treating a symptom? Is the real goal not just to de-bias our AI, but to confront and fix the biases in our society that the AI is reflecting back at us with such perfect and sometimes horrifying accuracy? That, I think, is the conversation we all need to be having.